everyone. So this is the continuation part for the last video. The last video is all about what is an algorithm and common terms in an algorithm. And today we'll be going to see about characteristics of an algorithm. Yes, now it is clear, right? Okay, now we'll continue. Characteristics of an algorithm. Algorithm is what? It is a step-by-step process to complete a specific task. So we are given with a task or we are given with a problem. To finish this problem, we will be going to write some process. Okay. Now this process, what we are writing, that process always needs input and output. The task or the problem will get solved using of step-by-step process, and this will have some input and output. Let's take some example that I am writing to perform. My task is to add two numbers. Okay, my task or my problem is to add two numbers. So what is the process I'll follow? I'll read two numbers. And I'll display the sum of two numbers. Read two numbers and display that sum of the two numbers, that is a plus b. Okay, now look at this. So here this is my process. For what I wrote this process? This process is to solve the problem. What is my problem? Add two numbers. So I am writing the process of algorithm in step-by-step process to complete it. Now this process is required some input to check my algorithm. Fine. Now what is the input of my algorithm? A comma b values. So that are what? 2 and 3. So this is our assumption. You can take any two values. Now what will be the output? Output will be the 5. So every algorithm is going to have input and output. At least one output we have to produce. Okay, that means if I don't have input, still my algorithm should produce an output. Okay, that's what I won't give a and b, I'll give 2 comma 3. That means 2 plus 3. What does it mean? So my algorithm will not wait for any input from the user, as input is already there in the program. So every algorithm must produce at least one output. Okay, now let's see the characteristic, the general characteristics of an algorithm. So every algorithm will have some input and definitely it should have an output. Input may or may not. That means if your input is already given, that means we will be usually calling this as in C language you might have studied this, compile time values and runtime values. As long as you don't have values in the program, you will be entering the values in runtime. That means when your algorithm is having scanf statement to read some value, and this is the value which will be given at runtime. So if this value is given in the program itself, in the algorithm itself, then it will be a compile time value. So now input will be given either from program or from runtime. Okay, but output should be at least one output. Our program or algorithm should produce at least one output. Now what is finiteness? Look at this algorithm. We will be having finite number of steps to finish this task or to solve this problem. So finiteness means finite number of steps. What do you mean by finiteness? Every algorithm should be written by user in finite number of steps. So you should not write any algorithm which will not finished in finite number. That means infinite number of times. You should not write. Your algorithm should be have finite number of steps. Now, effectiveness. What is effectiveness? Each line of the algorithm, each step of the algorithm should be able to produce one line of code in the program. So effective writing of source code. Look at this. When I look at the first step in my algorithm, now I can effectively put this line into my program, and that the line is int a comma b. It doesn't mean that always you have to give integer only. You can give float or double, or else you can give long int, long float, long double, short int. You can give anything. But the perspective is here when you can see one step in the algorithm, effectively that should be converted or that should be given into programmatical part. Okay, so that is what effectiveness. And look at the second one, display a plus b. Can I make effective program? Yes, I can make, which is printf percentile d a plus b. So I have two lines of code where I can put the two lines of code effectively in programming. So that is what effectiveness. And definiteness. Definiteness is something that we will be writing number of steps, right? Finite number of steps. Each step should have a definition. Each step should have a meaning. So that is what the definiteness and uniqueness or unambiguity. So here, if the first step is read two numbers, the second step should not be read two numbers, because unambiguity is unambiguity means no repetition of the step. Whatever step you are writing, that is unique, and this step is unique. You look at these two steps, this is different one, this is different one. We don't have any ambiguity. We don't have any ambiguity. Ambiguity means repetition. So here I have one step. The same step if I write here, then I should call this algorithm is ambiguity algorithm. But here two steps are different, now it is unambiguity. So having of all these characteristics if an algorithm in an algorithm, so that is what the good algorithm or completeness of the algorithm, characteristics of an algorithm. And next concept is generally we'll write algorithm can be written or represented in many ways. So the one is natural language, the general language, how the way we'll speak. And the second is pseudocode. It is an informal way, that is procedure oriented, informal way. And flowchart, graphical representation, programming language, and that is of structure oriented. So all these are to represent one algorithm. Okay, so this is what about the characteristics of an algorithm. Next video we will be going to cover about performance analysis of an algorithm. Thank you all.